Since we're at the top of the hour, I guess we should start. And yeah, thanks everybody for joining. There's still quite a good mass of people joining in, but let's just get started since we're at the top of the hour. Tom, you have your coffee, you have your water, or how do you wanna play this out?
I am good to go.
Excellent, excellent. Well, thank you for joining the webinar Wi-Fi Visualized the Basics. So this is a part one of a two-part webinar in collaboration with CWNP and Mr. Tom Carpenter. Tom, how are you, man?
Well, I don't look as good as I do in that image, but
You look
I'm
better,
doing
man.
well.
AI couldn't match you. But so here you did have all these amazing visualization tools in our practice, but then the machine broke down for whatever reason. So you're back in your library instead of the stage that we had set up. But are we still gonna get through today, visualizing everything you have?
I think we'll make it.
Excellent. And if you had to give, before we move forward, if you have to give the two key takeaways that we'll get today from your presentations, what would those be?
The two key takeaways are the power of active learning and then how to use the Hamina tools to do that. And so that's really going to be our focus today.
And what is active learning in this case?
Active learning basically means that you're learning by doing. So instead of learning by reading, learning by watching, learning by listening, you're actually doing the thing. And the research, and we'll talk about that research, shows us that it is the most effective way by far to retain knowledge and information, but also, and this is a key thing, to gain insights. And insights are key to developing expertise.
While this may be true, it is the least suitable method for us lazy people. Uh,
Here's
thank.
the shocking thing, though, Yusi. It's actually the best method for lazy people
Oh
because
gosh,
you
now you're
learn it
ruining it for me.
faster that way. You actually learn it faster that way. You would have to read and reread something multiple times to get the same level of
Yeah,
retention
this
and
is
insight
true.
that
This
you
is
get by
true.
actively doing.
And
And so you actually learn faster. Therefore, it's better for us, and I'll put myself in there, lazy learners.
all right, that's fair. That's fair. I appreciate that as a lazy overall person and learner. Well, Tom, as many people here know, but some may not, you come from CWNP. I just went to your website cwnp.com, and gosh, all the certificates you do cannot even fit on the website. But if I have to summarize this, like you guys do, these could be fit into two main buckets, if you will. Why with Wi-Fi you have like almost 25 years of history of certifying and teaching people about Wi-Fi, and a lot of the good Wi-Fi in today's world are because of you and the CWNP organization, and you have a big history in that, and I've had the pleasure of working with you guys for the last 25 years. And during COVID times, roughly, you guys started pivoting, and before that a little bit, you started pivoting towards IoT as well. So you have now two main buckets, Wi-Fi and IoT. Is that fair to say?
Yeah, well, we have two tracks is the term that we generally use because we want people to realize it is a learning progress that you can go through. And that's basically Wi-Fi and wireless IoT. And so the Wi-Fi track goes from the CWNA all the way through to the CWNE, being an administrator through to an expert. And the wireless IoT track does the same thing. Now, we do actually have a third bucket or container, if you will, and that one is our ancillary learning. So this would be things that are not necessarily dedicated to either of those tracks. And the one that we just recently launched, actually in the middle of December, was CPNAE, the Certified Python Network Administrator and Engineer.
That's
And we'll be
right.
launching 4 or 5 more in that series in the coming years. And these can be beneficial. People that have, for example, our um, expert level certifications that need to earn continuing education credits, they can use those to earn CEs. But they can also use them to simply learn new skills that are ancillary to what they do. A good example is Python. Python is a very useful skill to have, Python scripting, for Wi-Fi engineers, for wireless IoT engineers, and so forth. And there is some Python in our wireless IoT track, actually, in the CWIP
There is.
certification, but it's not as in depth as that standalone CPNAE certification. So, yeah, we've
Absolutely.
tried to build our certification programs to really help people develop expertise. That's the goal. And one of the things that I talked about in the WLPC evening presentation and so forth is what I call the myth of 10,000 hours. So you'll hear a lot about 10,000 hours is required to become an expert. Well, that has been generalized based on a book by Malcolm Gladwell
Yep.
called Outliers. But the research that it's based on is not generalized at all. It's very specific. The research it's based on was violinists. And so that was what was specifically studied. And 10,000 hours was the mean, meaning there were people that did it in less and there were people that did it longer. So there were people that did it in significantly less time and people that did it in significantly more time. So to just say 10,000 hours is what it takes is a very simplistic view of it. One of the most interesting things that you find is you can significantly reduce the amount of time it takes to get to the expertise level by having a mentor who is an expert and understands the best learning process to go through to get to that level of expertise. And that's one of the beautiful things about our certifications is that, I didn't just sit down and decide what we're going to cover in these. And before me, Devin didn't just sit down and decide what we were going to cover in our certifications, but instead we got teams of experts together and said, what do people need to learn here? And then what do people need to learn here at this level? So not only by going through our certifications do you have a mentor, if you will, that is helping you to understand what path you need to go through to learn this information, but you have a team of experts that are involved in this process. And what you're looking at there is our CWNE Board of Advisors, which we're just about to update, by the way, with a bunch of new people coming in and some people retiring. But in addition to all of them, we have the job task analysis teams that come together for each certification. And there's usually anywhere from 5 to 7 people involved in that. So you've got 5 to 7 experts that have gotten together and ultimately created what we call our certification objectives. And
Yeah.
those objectives are your learning plan that a bunch of experts said that's what you need to know. And a lot of people don't realize that when they look at objectives like this for certifications. Companies that do well, they have a team of experts that come together and help them to build those objectives. And therefore, you're effectively being mentored by experts in how to best
Yeah. Yeah.
learn this skill set, which is an amazing
Absolutely.
thing.
Absolutely. And like CWNP, when you start hanging out in the CWNP circles and going through your track of certificates, it's almost like WLPC, which is a conference or a set of conferences, Wireless LAN Professionals Conference. It's similar in a way that not only do you accumulate the knowledge during the WLPC conferences or CWNP track, you also get to meet the people and the experts behind them and things like that. It's almost as valuable to build that contact base. Anyway,
Absolutely.
quickly about me, I am Tom's assistant today. While I think I've been to all the CWNP classes actually multiple times. I have 0 certificates because I'm afraid I would fail if I took one of the tests. That's the honest truth. I could go on about I have no time, blah blah blah. I'm so busy, but that's not the truth. I'm just afraid. Don't be like me. Be like the braver guys and actually take these courses. Be like our VP of Business Development, who's now she went to the CWNA and will be taking her test soon as well. Also connect with me on LinkedIn if you want like a fellow Slacker, for example, for peer support who is lazy and afraid enough to not take these courses. Feel free to connect. Anyway, so today we're gonna look at visual learning of Wi-Fi and before we let Tom loose, I would like to take 90 seconds of some of the more recent things in Hamina that have appeared. I come from a place called Hamina, also from a company called Hamina, and we make Wi-Fi tools. And I just wanted to show you one thing here, or actually two. First thing might be like how to see your network. You're not just usually these kind of tools are just design tools and things like that. But what if you want to see your network and see how that truly works? Let's actually take a campus here, and it is in Europe. I'll just take the European campus. I'll choose the building. And let's say you wanted to see what's going on in your campus right now. I took an empty project in Hamina. All I put in was the API key of my site, okay? All I put in was the API key of my site. I click the button, and this is there for Cisco, Meraki, Juniper Mist, Aruba, NextGen Central very soon, Ruckus, Arista, things like that. And as I put in my API key, the entire site is then loaded for me. And if I want to see what's going on in my site, let's say somebody calls me when they're in trouble, I can instantly take my Hamina, take the correct floor, whichever floor it is, and start looking at, okay, what is going on in my network, and see how the heat maps are automatically traced for you. See how you can see, okay, here's my current coverage, here's my current channel utilization, here's my current interference levels. There's a little bit of interference, but there shouldn't be a problem. Let's say the problem was near this AP. I can actually take that AP and start testing against it, see everything that's going on in that AP. Let's say this is actually the problematic client device. I can take that client device and start looking at the client, see where it is, see the data rates, see the signals, everything about that. So, and this is a non-cooperative client. So this is the kind of visual things that we'll see today and in the next version over as well. But it's kind of like these are not just your site survey and planning tools anymore. These are live network status analysis and testing tools. And now, if this client had actually a bit of a problem, this data would be saved for you as a PCAP as well. So whenever you're looking at a client device, we save that as a PCAP. All the communication will be there for you to look at, assuming you've passed your CWAP, okay? More about the CWAP also in our next webinar. The other thing that I may still have 30 seconds. The other thing I quickly wanted to show is this. So I went to Mobile World Congress in Barcelona. When was it? A couple of weeks ago. And if I wanted to do a design on the floor that my hotel room was in, and Tom, you may not have even seen some of this stuff. So I can start designing the network straight off the bat. I'm gonna put in just the latest and greatest Wi-Fi 7 APs here, 9176 eyes, and created quick plan for that, and see on this photo that I took with my iPhone, how come it's actually limited to the building, the whole coverage heat map. How can it know that? How did it know the scale of the drawing? How can it do all of this for me automatically? Well, and how can it, if I move an AP, how does it know that the signals stay in the rooms, but they actually go further in the hallways, things like that? Remember, a photo taken with my iPhone. How can it do a three-dimensional model out of that? A photo taken with my iPhone. It is because we actually read the walls, the scale, and the extents of the building. Using machine learning, we actually figured out where the walls are, what the scale of the drawing is. We figured out what the areas of the drawing are, things of that nature. So in a sense, it's instant network design. And then you can put in your usual like switches, and it keeps track of your PoE budget, your port budget. What if you want to do the cabling properly? Then do the cable trays, and you can see this, the AP cables follow the trays and things like that, and then off to a bill of materials. But anyway, point being, some pretty major updates in Hamina that we will see some of these also in Tom's next week's presentation probably. But this week, Tom, you took on the challenge of using the free version of Hamina to teach Wi-Fi concepts. Is that right?
That's absolutely correct. And I will warn you, when I go to the advanced in part two, I won't use that feature because that feature makes it to where you're not learning how to create walls. And so I want to make sure they know how to create walls and how those walls impact it. But with that said, that is an astounding feature. And just the fact that it generates it, and then of course you could go in and tweak it. You could change the wall settings if you needed to. But the fact that it can generate that automatically is something that is super valuable because it means I don't have to have an AutoCAD floor plan anymore to get some automation in this process, which is super beneficial.
That's excellent. That's excellent. I really look forward to part two, but should we get started with part number one, Tom? What do you got in store for us?
Oh, absolutely. Let's go ahead and jump right in. So, what we're going to do here is today we're going to have some slides that I'm going to cover some important information in before we get into some demo. And then, of course, next time we won't do the slides. We're just going to be doing demo the whole time. And our focus, though, remember, both here in part one and in part two, is how to implement active learning by using these tools. And we're using the Hamina tools. And by the way, I've meant to ask you for some time, does Hamina mean something?
Yeah, that's a good question. It actually is a city in Finland, and my mom, hey mom, still lives in the city of Hamina. That's where I was born and raised. It's a very small town, and somebody said once, "Oh, you're from Hamina. Is that the city with more jerks than inhabitants?" So it's not a it's a it divides people into two camps. Some people or most people from Finland know Hamina because of a couple of things. First of all, it had a big paper mill that was turned into an enormous Google data center, actually, because
Okay.
paper mills also are built by the water. There's a lot of cool water there, so there's an enormous Google data center. The other thing is a lot of people have went to the army in Hamina. It is fairly close to the Russian border, actually. Not that the
Okay.
army and the Russian border are in any way related.
Excellent. Well, that's actually very interesting. So, named after your hometown. I love it. Okay. So, what we're going to do is we're going to go over the reason why learning is important to you, first of all. And then, second of all, we'll get into this topic of active learning and why it's important. And then we'll jump in to see how do we do it. So, the first thing is the reality that there's one thing that's certain about our future, and that is uncertainty. So, when we look at career management, for example, we 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 talk about things like teleological versus aleological career management. And teleological, so teleos means the reason, the purpose, the plan, why. Um, Alea from the Latin simply means coincidence, occurrence, something that happened. So what we're doing is we're saying we want to have a teleological career plan instead of an aleological career plan because we want to have one where we're working with intention toward our career. That's not to say that there is no uncertainty, that there won't be what the research literature calls happenstance. But what we want is we want planned happenstance instead of unplanned happenstance. In other words, we have occurrences that take place within the reality of a plan rather than simply going along with no plan for the future of our career. So, yes, there's uncertainty. Speed of communication increases. Organizations are changing their structures. We've seen obviously a movement toward more and more people working from home around the world in different areas. The speed and extent of change, it just keeps on changing faster. And because of the fact that we can process, parse, analyze, and gain insights from information faster today than we could 4 years ago, thanks to large language models, we're seeing that speed and extent of change increase even more. And so, what this drives then is a need for lifelong learning, learning across the entire lifespan. And that's going to be very key for us to do because we're dealing with this VUCA model of the world, which means that we have volatility, we have uncertainty, we have the reality of complexity, and of course, ambiguous events. And so this is what is called the VUCA model. And basically it says that this is the world that we're living in. Now, given that we're living in this world, we want to have a framework that we can work with. And one of the frameworks that I've come across that I really like actually came from a research paper from 2009 called the Intelligent Career Framework. And what they focused on was knowing why, knowing how, and knowing whom. And basically, knowing how is your skills and expertise, right? Your ability. Knowing whom is your networks and your relationships, and knowing why is your motives, your values, your interests, your motivations. And most people never stop to think about these things when they're looking at their career and where they want to go in their career. For example, they might simply say, well, I've decided that I want to become a Hamina master. I want to know it better than anybody else in the world. Well, why? So have you actually asked why? You need to find your reason. There's a reason there because you came up with that idea, but sometimes we're not aware of what's motivating us to do that. We don't really stop and think about it. Knowing your motive helps you stay on track. You may have noticed you start to study something, you start to learn something, and then you give up a short time in. And one of the reasons for that is we forget to focus on our why. And so because we didn't ever consciously document or analyze our motive, our why, we lack the ability to fall back on that when we come into hard times. And everybody's going to come into hard times. It doesn't matter what you do. Let's say you want to start exercising. The first day you go in there and you start exercising rigorously and you feel so good when it's done. But then the next day you don't feel good. You feel bad. You're sore all over. You're having pains in places you didn't know you had. And so the point is, if I'm going to keep going, it's not going to be because I felt good after the first time I did it. It's going to be because I remember why I'm doing it. And that lets me push through the pain. So this is just a very important thing. And it applies in areas of intellectual advancement as well as physical advancement. And so if you want to keep on learning, you're going to have to know your why. The other factor that helps you keep on learning is knowing whom. The network. This is so key. This is why researchers tell us if you want to become an expert or maybe just advance your knowledge in an area, even if you don't want to become an expert in that area, that if you really want to be able to have stick-to-itiveness, other people need to know you're doing it. Other people that you trust, other people that you rely on, other people that rely on you. When those people know you're doing it, that becomes a motivator to keep you going forward because now you have this person to answer to, right? So this is why mentorship is important. And mentors are not always people that are technical mentors. They can be motivational mentors. They can be your peers that are really at the same level as you, but you're just communicating with each other about how your learning is going and how your advancement is going. And that kind of thing helps to motivate you because the next time you meet them and you talk to them, you want to be able to share with them how you've grown, how you've advanced. And so knowing why, your purpose, and knowing whom, your relationships become motivators to advancing your knowing how. A very key thing, a very, very important thing to understand. Another thing that's important to know about this space that we live in is that skills disruption is normal. So we get into these phases where we think, oh, large language models, they've changed everything. There's always something that has changed everything. It's disrupting the skills. Look at this chart. This is 2016, 2018, 2020, 2023, and 2025, the expected future disruption of skills. And yes, 2020 gave us a significant disruption outside of the norm. But if you take that, which we all know the obvious reason for that, if you take that out of the picture, you see that the disruption of skills is fairly consistent. And that's what we've actually seen over the last 30 years. So the expected disruption of skills in the next decade is actually not expected to be any different than it was in the last decade or the decade before it. Now, if you take a 30-year window, you will see skills that 30 years ago people were saying were very important to develop, and no one cares about them today. That's reality. That's why I wrote blog article many years ago called "You Ate Your Cheese," because the famous book "Who Moved My Cheese," deals with the issue that people, like rats in a maze, they know how to go and get the cheese, and so they just keep going to where the cheese was, expecting it to always be there. And the message in my blog post, "You Ate Your Cheese," is that in the technology sector, if you have a certain skill set and you think you're going to be able to eat off of that skill set for an entire career, you're mistaken. That cheese is going to get eaten up and you're going to need new cheese. And that means that you need to develop a new skill set. Very, very important to understand. What are the core skills expected in the future? Well, according to the WEF's Future Jobs Report from 2025, literally published on January 7th of this year, so very new data, here's your skills. I'm not going to read all these to you, but if you want to look at these, or I'm assuming this webinar is going to be archived, you can come back later on and hit pause. You can do a screen capture real quick while I sit here for another few seconds. The point is, there are a lot of skills that people are reporting are going to be very important for the coming years. You won't be able to master all of these. I know you'd like to think that you can, but the problem is, by the time you master all of these, it will be a somewhat different set of skills. So you've got to pick the thing that you want to focus on. And of course, here today, people are very interested in wireless, and that's their specific technical focus. But look at this. What are some things that apply to wireless on this list? Well, we just saw one of them earlier. UC showed us machine learning based reading of a flat 2D picture of a floor plan converted automatically into a 3D floor plan. Well, how was that done? That was done with artificial intelligence, right? And understanding the links of artificial intelligence into our systems allows us to better understand what they can do for us. I recommend everybody have a moderate level of understanding of how AI works. And I don't just mean where to click to make AI happen. I mean understanding, what are these things called neural networks, and what are these things called attention models? And understanding that helps you to understand why AI works the way it does, but also where it is applicable and, frankly, where it's not. So these are the skills coming. Here's a list of the skills on the rise. Again, I'm not going to take a lot of time on this. I'm going to move on very quickly. But the key thing to note is the AI and big data, obviously the largest one, but look right there under it, networks and cybersecurity. And so this is, again, according to the WDF from their January 7 report of this year. So obviously, when you're looking at wireless networks, a subset of networking and cybersecurity, you're looking in one of the big areas of growth for the coming 5 to 10 year period. Now, I'm going to share this with you very briefly. And there is a WLPC presentation of this, a brief presentation that covers it in detail. So I'm not going to go to it in detail here. But it's something I call effective foundations theory, which says that we need to manage 3 areas of capital: our intellectual, our performance, and our relational capital. Intellectual is your skills and your ability to develop more skills, or learning ability. Performance of capital is the ability to get things done, your ability to be focused, to plan, to organize, to establish and meet goals, and so forth. And relational capital, of course, is your social network and the ability to develop that network. We grow our capital through grit, learning, and self-awareness. And our focus here today is on learning. If you want to know more about this, check out the WLPC video that posted from this year's WLPC conference. Career management configuration. This is the one of the last couple of things I want to talk about before we get into some demonstration here. The big one is on the right. We have here decision making with either more causation and less effectuation, or more effectuation and less causation, or somewhere in between. But this is a concept that I fell in love with when I came across it. This was reported in a research paper in Strategic Entrepreneurship Journal in 2017. And by the way, you'll find that I talk a lot about things in research papers. I spend a lot of my time reading research and not just research related to wireless. So I love reading the research and finding out how we can better ourselves and how we can accomplish more in our careers. Well, here's a cool thing to think about. And this is why I love companies like Hamina, because they're focused on effectuation and not causation. So what's the difference? Well, when it comes to making a decision related to your career, you have the choice to make a cause-based decision or an effect-based decision. A cause-based decision means that you're simply responding to what happened. An effect-based decision is you're deciding to make things happen. Now, I want you to pause for just a second and think about the impact of what I just said. Do you want to be the person that's always responding to changes that other people are causing? Or do you want to be the person that's causing the change and hopefully change for a better? But the point is that if we really want to have the biggest impact through our expertise and through our careers, and we want to look back at the end of our lifespan and say, I'm happy with what I've done with my life, we're going to make more effect-based decisions than we are cause-based decisions. In other words, every time we look at a turn in the road, we say, what decision is going to help me have a greater impact? Instead of what decision is going to impact me less in this moment. Wow, that's something to think about. And so that's the difference between effectuation and causation. And the big thing is, I want to be an effectuation person. I want to be effectuating change. I want to be driving change for the good in people's lives. And a lot of people ask, what's CWNP's driving mission? We have internal meetings. And when people ask in those internal meetings, what is our driving purpose? It's a simple statement that I always make: to make the lives of technical professionals better. Now, you might say it's to educate people about Wi-Fi. It's to make people experts on Wi-Fi or on wireless. That's what we do in a practical action, but the driving force behind that practical action is to make their lives better. And that's what motivates everything we do. That's the driving motivation. I think it's safe to say that, Hamina's driving motivation is to make wireless designers' lives better. You think about that feature of converting a picture into a floor plan. Um, you know, could the engineer have drawn the walls themselves? Absolutely, they could have. And you know what? They might even need to in some cases. But the point is that they create a feature like that to make your life better on a day-to-day basis when you're working with the tool. They don't create a feature like that because it was just something fun for them to do. It might have been fun for them to do, but that wasn't the motive behind it. The motive behind it is, how do we make people's lives better when they're working with this tool? And if we do make that our driving motive, we're in that effectuation category and not in the causation category, which is an amazing thing to think about. All right. Our goals then, when we set our goals, there are three types of goals: mastery, performance approach, and performance avoidance. These are your learning goals. So when you sit down and say, I want to learn X, the question is the why behind that goal. If it's a mastery goal, this is the primary, most ideal form of goal. A mastery goal is that you want to learn it because of the achievement value that it brings in your life. And we find that mastery goals increase enjoyment, reduce boredom, reduce anger, frustration, all of that. Performance avoidance goals are the worst kind. Why? Because we're setting a goal in order to not fail. We're setting a goal in order to not come in under someone else's bar. And what this does, it leads to anxiety, hopelessness, and shame. So the ideal goal is a mastery goal. The worst goal is performance avoidance. And there in the middle, you do have performance approach goals, which are better than performance avoidance. And sometimes we have to set performance approach goals because someone else sets them for us. So when someone else sets a goal for you, what you want to do is stop and ask yourself, why do I benefit by learning this skill? So what benefits me in learning this skill? And that's going to turn it from an avoidance to an approach goal. But a mastery goal is always internally motivated. It's driven out of intrinsic motivation. If you want to study something interesting for your life, go to your favorite large language model tool and say, teach me about self-determination theory. Self-determination theory, or SDT, is one of the longest running theories of human motivation that's out there, dating back to the late 1970s. And one of the big focuses in that theory is on developing intrinsic motivation and using intrinsic motivation as the source of your goals. So really good things to look at there. So why do we want to study this active learning then? Why do we want to make sure we're doing while we learn? The psychology of doing it, this is interesting. So first of all, free recall memory performance. Free recall is basically our ability to recall information when asked about it after a learning experience, okay? So verbalizing on the right side over here, look at that graph. Verbalizing is the darkest bar. That means we're not active. It's simply verbal learning. Acting no object, what would that be? This means we're just physically acting while learning, but not necessarily interacting with an object related to the thing we're learning. And then acting with an object is where we're actually interacting with the thing we're learning about. So the ideal is obviously acting with an object. So for example, learning about RF propagation by using something like Hamina's wireless design tools. And so you're not just reading theory, you're actually interacting, changing settings, changing configurations, seeing how it impacts the RF propagation. You're learning by doing. Notice that it is about twice as effective when you're learning by acting as opposed to just learning alone. That is a massive difference between the two. But also, I want you to notice, and I'm drawing this to your attention because I'm getting older. When we get older, we learn more difficultly. It's a greater challenge to learn the older we get. That's just a fact of life. But I want you to notice that the 69-year-olds over here on the right are learning just as good as 25-year-olds. Okay, I'll round up to 26. If the 26-year-olds are doing verbal with no object and you're doing acting with an object. In other words, if you use active learning, you learn as well as a 26-year-old again if they're not using active learning. And by the way, most of them are not. So this is really cool. This is an amazing way to improve your learning. So if you haven't been using active learning, start using it and use it strategically, because you will find that you greatly increase your retention by using active learning. It comes out of something called experiential learning theory. And experiential learning theory basically says that we're going to have a concrete experience. We're going to reflect on it. We're going to abstract insights from our reflection on the experience, and that's going to lead into active experimentation, which leads to a new concrete experience, reflective observation, abstracting our insights leads to another active experiment. And so we go through this cycle of learning, and it's a very powerful way to learn. John Dewey said all the way back in 1938, I take it that the fundamental unity of the newer philosophy is found in the idea that there is an intimate and necessary relation between the process of actual experience and education. It's sad how we often forget what we already knew. Experience enhances remembrance. So we have two primary methods of encoding, semantic and enacted encoding. Semantic encoding gives you one level of retention. Enacted encoding increases it by 20 to 40%. And enacted encoding means motor imagery, observation, or self-enaction. And basically, in other words, we're doing, right? We're doing something. And even, this is the great thing, just imagining you're doing it improves over just semantic encoding. Just imagining it. You can sit down and just visualize yourself doing the thing, and it actually encodes the information better than not doing it. All right, final piece, free recall versus queued recall. Free recall, tell me everything you know about the four-way handshake. Queued recall, explain why the frames are different sizes for each of the four messages in the four-way handshake in this PCAP file. What's the difference between those two things? Well, free recall is beneficial, but the problem is that it doesn't help to better encode the knowledge in your brain. Queued recall has been shown scientifically to better encode the knowledge in your brain. So explain why the frames are different sizes. So instead of just understanding the four-way handshake, you're looking at a PCAP file. And when you look at that PCAP file, you notice that the four messages are different sizes. Actually, two of them are the exact same size, and then two of them are different sizes. So you notice this information about it. Now you ask, why is that? So you start digging into it and you find out that, well, the third frame is the size it is because it actually has more information in it. It has the GTK encrypted and stored in that third message. And so that makes it much bigger than the other frames, right? And then the fourth frame is smaller than the other three because it has less information. And you can look at what that less information actually is. The point is, you're encoding knowledge about the four-way handshake in a much better way than you would if you're just reading one of our books, for example, that describes the four-way handshake. You're actually looking at that PCAP, you're engaging with it, you're enacting it. It's an amazing thing that you can accomplish with that. Well, let's do it. Okay, so here we're looking at the simplest thing that you can look at. A simple rectangular floor plan, all right? So very simple because we're not focused on designing wireless for an environment in this demonstration. Our focus here is going to be understanding some of the things you learn in CWTS, CWNA, CWISA about RF behaviors and RF propagation. Because it doesn't matter if you're studying 802.11 Wi-Fi or if you're studying 802.15.4 for ISA 111A, wireless HART, or something else, or if you're studying, sub 1 gigahertz protocols like Sigfox, LoRaWAN, Wi-Fi Halo, whatever those things might be, or if you're studying, 3.5 gigahertz private, or if you're studying 6 gigahertz Wi-Fi, or maybe you're studying terahertz, whatever you're studying, you're studying RF. And there are mathematical properties of RF, right? So we learn things. We learn about dB math when we're studying Wi-Fi. It's one of everybody's favorite parts of CWNA is spending an hour learning about dB math. I'm saying that as a joke because everybody's afraid of it. But the amazing thing is when they come to one of the classes that I teach on it, one of the most common comments I get from people on the break after we get through that section is, that wasn't bad at all. And the reason is it's not. It doesn't have to be because I actually teach it the way we're going to look at it right here. So let's get some help from our friend Gemini. Now, with Gemini, if you were to prompt it saying, with RF propagation, every doubling of the distance results in blank the power. And then it goes into this and it says, well, when discussing RF propagation and the relationship between distance and power, it's crucial to understand the inverse square law. Here's the breakdown. In ideal conditions, free space, the power density of an RF signal decreases proportionally to the square of the distance of the source. This means that if you double the distance, the power is reduced to 1/4 of its original value. Okay, that's interesting. So if the power is reduced to 1/4 of its original value, can I do some active learning and figure out, therefore, you can double the diameter of an AP's cell size in free space. This obviously doesn't work in an indoor environment because you have varying walls that attenuate at varying levels. And so you can't do free space calculations for indoor propagation, right? But let's just play this out. You can double the diameter of an AP cell size in free space by changing the output power from 3 dBm to, I wonder what I would need to do. Now remember, we learned right here, Doubling the distance results in 1/4 of the power. We know that. So now we're playing with our 3 dB rules, and we're saying we want to then double the diameter of the AP. So we're playing with the same concept, but we're kind of inversing it. Rather than saying if we double the size, we have 1/4 of the power, what we're saying is, how do I double the size then? How much more power do I need to double the size of the cell? And let's take a look at this. So for example, we have an AP here. This happens to be an Aruba instant on AP32. We're only looking at 2.4 gigahertz. You can see that down here where we've configured our Wi-Fi coverage, and I've selected only 2.4 gigahertz because that's all we need to look at in this case. And we see that we have, just look at this green part in the middle. You know, this is our high coverage signal strength. So we'll just look at that green part in the middle there. And I'll show you a little trick here in Hamina. A lot of people know that, you know, when you first bring in a floor plan, if you're doing this manually, you need to go to scale. It's the first thing we learn about Wi-Fi design tools, right? First thing you should do after you import a floor scan, scale it. Make sure that you have the right dimensions. So I've already scaled it, and I have my scale here. And so what I did is, whoops, let me do this again. I simply clicked right here, drag over, click right here, and I just lied and said it's 400 meters, okay? So I've already got a scale set, all right? So that's where this comes from. But what you may not know is you can draw a line anywhere you want now, and it will tell you how long that line is based on the current scale. So if I cancel that, my scale's still there, right? So let's take a look at the diameter of this, and we don't have to be exact because we're learning. So I look at this and I see 37.25, so we'll go with 38 meters. Okay, so it's 38 meters right now. I'm going to go back to my edit view here and click on my AP. And what I'm going to do, I want to double the cell size, right? So the intuitive thing most people would think is, well, if I set this from 3 dBm to 6 dBm, that should double my cell size, right? Well, we'll try it and let's see the result that we get. It increased it, but is it double? Let's go back to our scale size. We'll draw our line roughly again, and it's 53.33. Well, that's not quite double, is it? Let's try something else. Let's go back to our AP, and let's set it to 9 dBm instead of the original 3. And now we'll go back into our scale. We'll take a look at it. Again, it doesn't have to be perfectly exact. We're just getting a rough measurement here. So 75.29, right? Just for a reminder, let's go back to 3 dBm and remind ourselves of what it was. And we see our scale size here. It's about 38. Multiply that times 2, you get about 76, right? And so by going up from 3 to 9 dBm, we have doubled our cell size. Or let's think about this and see what we've learned here, right? So let's go ahead and take a look at our original question. Therefore, you can double the diameter of an AP cell size in free space by changing the output power from 3 dBm to blank dBm. And then look at the explanation. One of the great times when LLMs actually get it right. And what we can see here is it says, to understand this, we need to connect the relationship between distance, power, and decibels. Here's a breakdown. Distance and power. As established, doubling the distance results in a quartering of the power. So we can't just go from 3 to 6. That wouldn't make sense, would it? We need to quadruple the output power if we're doubling the distance, because the inverse, remember, is when you double the distance, you have 1/4 of the power left, right? So if we're wanting to double the cell size, we actually have to quadruple the output power. And so that's what it tells us here. A change of +3 represents a doubling. A change of -3 represents a halving. A change of -6 represents a quartering. So to double the cell size, you need to increase the power by a factor of 4. An increase of power by a factor of 4 is equivalent to an increase of 6 dB. Therefore, if you start with 3, you add 6, you have 9 dBm. The answer then to our blank is 9 dBm. Now, the point here is you could understand that by just reading a book. Sure. You could understand that by just watching an e-learning video or something like that. But you'll never understand it as good as you would by actually coming in here, putting the AP on the map, measure the cell, now double the power, measure the cell, quadruple the power, measure the cell. In a simulated real environment, you're actually seeing the inverse square law play out. You're actually seeing the results of it. And trust me, you will remember it much better by doing what I've just gone through here than you would by simply reading a book. Now, let's take another example here. You know, one of the things that we learn about in both CWTS and CWNA is antenna charts. So we look at the propagation pattern that is used from for either internal AP antennas or external antennas that you can purchase, things like that. And the reality is that a tool like this can help you study and learn those as well. So for example, right now, we're looking at that wrong mode here. Let me get back over here. We're looking at that Aruba AP, and I just happen to have it pulled up over here. That AP is right here. We're looking at our antenna charts. And so,
Hey, Tom, I wonder
yes.
if in the free version you can actually enable the antenna charge also in Hamina if you would like for this. If you go to right click, or sorry, click at your name on the top right corner, and then go to preferences and internal antenna pattern viewer. You get a little bit of reference there as well. All right. And now, yeah, click on the AP model again on the right-hand side. There's the drop down. Sorry to disturb you. There you go. And now scroll or like highlight one of the APs. There we go.
Yep. Yeah. So what? But that defeats my purpose. Great feature.
Oh, sorry, I ruined the webinar. Well, it wasn't the first one.
Great feature. But what I'm wanting to help people, encourage people to do here is to go dig. Now, again, remember the motivation that UC's team has is to make your life better when you're designing a wireless network. And that's exactly what this does for you. As a learning tool, this is also beneficial. You know, I can see, for example, for my AP32, I can see the 3D view, which is a really cool feature of getting that.
But it doesn't give out the details like where you were going. Kind of like, you know, for example, it doesn't even give you the reference scale of the patterns in E and H plane.
Yeah, exactly. So you're not going to get all the details. So here's my point. When you're studying antennas and antenna charts, don't just read the book. Don't just watch e-learning. Don't just be satisfied even with the class. You know, the instructors in the class, they'll bring up different antenna charts, talk you through them and things like that. Go do your own exploration. Go and study. Yes, it can spin around. Go and study what you can learn on your own. So what I do is I take this AP that is exposed to me here, and then I go and I look at the antenna chart and I say, okay, you know, based on this antenna chart, I can see how that propagation pattern is being generated over in the design tool because I'm actually looking at the propagation of that particular antenna. And then I can take my skills that I'm learning in CWTS or more so in CWNA. I can take the skills that I'm learning there and I can say, how do I read this chart? Make sure that you can understand it and process the information. Look at the difference between the horizontal plane and the elevation plane. Okay. And then you are actually using active learning because you're going out and doing something. See, some people have the mistake of thinking that active learning can only apply to things that involve physical activity, like you know, taking a tire off of a car and then putting it back on. That they think, well, yeah, you can do active learning with how to change a tire, but how would you do that with learning antenna charts? By simply going and exploring. and looking at the different charts for different devices. So for example, if we look here at the Ingenious ECW 526 specification sheet, and yes, there are other things you should be looking at in your learning process in a spec sheet like this too, but one of the things it's going to give you is your antenna charts. And so you can look at those, and then you can go over into the tool and change your AP to an Ingenious ECW 526. I think 526. Yeah, that's what we looked at. And so I can already see here the chart. And when I select it, I can see how it changes the propagation pattern based on the different antennas. And then, of course, you can go even further and you can study how, having the internal walls in your building are going to impact it and so forth. And this is just a wet the whistle demonstration because the next time, as I said, we're going to be doing nothing but demonstrating things the whole time at that CWDP and CWAP level. But what I would encourage you to do is, you have access to this. I think that UC is even giving you something special for attending the webinar. So, you've got special access to features and capabilities. Come in here and look through the tool and ask, how can I use it to study the things that I'm studying for CWNA or CWTS? Or even a vendor-specific certification, like maybe it's a Cisco certification where you need to have some wireless knowledge. Whatever it is you're studying, use the tools to go in and learn about it. And one of the creative things that you can do nowadays, and I'll turn it back over to UC after this, but a lot of people don't know about Google's AI Studio. But if you go into Google's AI Studio, you can actually share your screen. You can stream your screen to it, that AI, and you can show it the different interface features and things like that. And then you can simply ask it, hey, how might I use this to study for the CWNA exam based on the objectives they make available at their website? And believe it or not, that tool, having never seen this tool before, can look at it on your screen and the features it offers, and it can give you advice about how you could go about studying for those objectives. Pretty cool stuff. And then you can go through that learning process. All right, so with that, we'll go back over to UC for Q&A that we have here in the time we have left together.
Absolutely, absolutely. And I was just trying to search the link for retrieving your free 30-day Hamina license for when if you're CWNX certified. So, and Andrew, if you don't mind, if you can find it from somewhere, let's try to search it for people. Otherwise, just email me and we'll find it. Jussi at hamina.com. I almost put it there on the chat board as well. If we can't find it, just email me and I'll dig you out the link. Thank you, Tom. This was fantastic, and a fantastic kind of like segue into active learning and the benefits of active learning, and then actually doing the active learning, and then what are we gonna do and see next week before we get into the Q&A? Like, if you had to summarize, not next week, next webinar in a couple of months, like what would be the three takeaways we're gonna have next?
Absolutely. So the big thing is we're going to do, mostly we'll be focusing on learning Wi-Fi design. That is the primary use of this tool, for example. So that'll be mostly what we focus on, but we'll be looking at learning how building materials impact your design and understanding that, because one of the great things that expertise develops, right? If I give you an example, a few years ago, someone said to me, hey, we're moving into a new small facility for our office. It's got like 9 rooms, and what do you think we need for Wi-Fi design? And I said, well, can you pull up a floor plan? And they said, oh yeah, we just leased it and I can get the PDF of the floor plan. So they showed me a floor plan and I said, I don't know exactly what the walls are made of, but just looking at that floor plan, I would predict 3 APs and you're going to have a phenomenal network that's going to do your work. And then guess what? They put the 3 APs where I told them they should probably put them, and it worked. In a small scale solution like that, over years of doing it, you are able to intuit it, but you're doing it because over those years, you've had different wall materials and you've seen the impact of those different wall materials. The beauty now is we can go into a tool like Hamina and we can just plug in different wall materials and immediately see the impact that it has. We don't have to wait until we have an actual project where we get to work on that. So that's one of the big takeaways, is understanding how building materials impact your design. The other one is learning the concept of capacity, and really seeing how with a tool like this we can master the knowledge and understanding of capacity, because it's one of the key elements in our wireless designs. And then the third takeaway will be, we're going to play around with some PCAPs, right? So we'll take a look at the PCAPs and we'll talk about, all right, how do I learn by looking at captures of wireless communications? Because that's a very important skill to develop, and of course helps you on your way to your CWAP.
Sounds fantastic. And by the way, speaking of next webinars, not only will Tom be on again in a couple of months, but also the CEO of Wi-Fi Alliance, Mr. Kevin Robinson, will be up next, I think, towards the later part of April. So stay tuned. Follow Hamina, follow me on LinkedIn, follow Andrew, and we'll be posting about the new webinars coming up as well, and sign up to our mailing list, something like that, on our website as well. Should we take a couple of questions, Andrew? Has there been any questions, and what is the common theme? Is there a common theme on the chat? The chat I have been following, and it's been really fun to watch. But has there been something? I know there's actually been a lot of like Wi-Fi noobs here as well, and people who haven't gotten into Wi-Fi too much, and that. Thus, the introduction was really good. But have we had any questions?
Yeah, absolutely. I think the theme in the chat, Tom, was that you're putting a voice to many people's internal feelings when it comes to learning. There was many people recognizing what you were saying and how they feel about their journey and their qualifications. So a lot of hugging and maybe some tears in the chat. I think probably my favorite question was, where did Tom get that shirt? So I don't know if you made it yourself or it's available somewhere.
I believe it was an Amazon purchase. I was doing some videos for someone on the command line scripting at the Windows command line. And so I wanted something to wear during it. And I'm pretty sure I just went to Amazon and searched for Run CMD. And there were several different examples of it. This one has a nice little graphic of a computer screen with the command prompt. Yeah, so I'm a big t-shirt guy. So you will never see me in anything but a t-shirt unless I'm teaching a CWNP class or maybe at a conference, and then I'll wear a CWNP golf shirt. But other than that, I'm in some kind of a creative t-shirt most usually.
There we go. It's an awesome shirt. The question came in a bit late for me to interrupt you at the time, but somebody basically came back and said, why is quadrupling the power not 12 dB? So I think you said it was 6
good
dB,
question.
not 12.
Yeah, that comes down to the dB math. And so, what I always tell people in my class, first thing I tell people when we're studying this, is to remember the rules of tens and threes. And the rule is simple. 10 is 10 and 3 is 2. If you just start with that and you remember that, 10 is 10 and 3 is 2. Because all of our actual math that we do will be based on 10 and 2, not 10 and 3. Because it is it's logarithmic math. So 10 decibels is 10 as a factor. So therefore, if I add 10 dB, I multiply by 10. If I subtract 10 dB, I divide by 10. But 3 is 2. If I add 3 dB, I multiply times 2. If I subtract 3 dB, I divide by 2. So therefore, a factor of 4 is 2 3 dB changes. So if I add 3 dB twice, that is the same as multiplying times 2 times 2. Or if I subtract 3 dB twice, in other words, I subtract 6 dB, that's the same as dividing by 2 and then dividing by 2 again. So that's the reason it's 6 and not 12, because My actual calculation flips over to the normal base 10 math we're used to, but in base 10, 10 is 10 and 3 is 2. And as long as you remember that, you'll have your rules of 10s and 3s down.
That's exactly what I said back in the chat. So yeah, brilliant. Bit of a better explanation from Tom there. Go on, Jussi.
No, go ahead, Andrew.
So the last one I'll call out, because a couple of people asked it, is will we get information next week about the revision to CWAP 405 and things like that? So if you weren't planning to, can we get a bit on that next webinar, Tom?
Actually, I can tell you now that it is launching on April the 2nd, and all the materials will be available, the objectives will be available, all of that. So the new version of CWAP, version 405, is launching on the 2nd. The as far as content goes, it's basically that it now does also cover 11BE. And it's based on 802.11 2024 as the most recent roll-up. And so, that's the most significant change, though, is it's covering 11BE or Wi-Fi 7. Other than that, it's still the same, as far as content, the same coverage as it was before. So if you're someone that's been studying for it and you missed the window to get in on CWAP 404, it's not that big of a deal. The only extra knowledge you'll need to get is 802.11BE. Not much there.
Hey, on this standards discussion, and this is a question I get very often. Like, Tom and Andrew, what are your favorite things about Wi-Fi 7? Or kind of the thing that you mostly anticipate about Wi-Fi 7 when the rubber starts meeting the road? What will be the big deal? We know the features, but what do you expect to have an impact in the real world?
I think long-term multi-link operation is going to be very interesting to see. I don't care honestly about laptops and tablets and things like that for the most part. For me, the uses of that are going to be interesting are going to be what can be done with some very creative IoT that not everybody thinks of as IoT. We're talking about VR, AR, video streaming, high data rate, that type of thing. It's going to be interesting to see the use cases of that come out in the next decade. It's really funny because I was just reading some research papers on virtual reality last night. Yes, this is what I do with my evenings. These were actually written and published in 1991. So to put this in perspective, and it was interesting to be reading about virtual reality from over 30 years ago and the excitement that's in these papers about what's coming in the next 3 or 4 years. Needless to say, it took a lot longer than that to get here, but I do think this decade is going to be an AR VR decade. I think it is. I think we're going to see it wildly and heavily used in safety related manufacturing, mining, drilling, all of those types of worlds where keeping people away from it is a much safer thing than having people in it. And that requires some very reliable links and possibly, depending on what we're doing, extremely high data rates. So it'll be interesting to see how multi-link operation plays into the benefit of that with Wi-Fi. I'll be honest with you, it's just going to blow people's mind to hear this from me. Other than that, I'm not really excited about much that's in Wi-Fi 7 right now. There's nothing in it that says to me, oh, this is going to change our world in Wi-Fi in the next 5 years. I think 11AX did that. 11AX with OFDMA was a game changer, particularly for IoT. And I think a lot of people miss that in the Wi-Fi space because they don't think about it from an IoT perspective. But 6 gigahertz Wi-Fi with OFDMA is a game changer for the possibility of use for Wi-Fi to be able to handle tens of thousands of devices in a large scale manufacturing environment. It can actually do it, whereas before it couldn't. So that's very interesting to me.
That's an interesting take, yeah, about OFDMA and the IoT link. I think the industry doesn't talk about that enough. Maybe that's something to raise up also in the next one. What about you, Andrew? What's your kind of like Wi-Fi 7?
Well, I'm going to come back on the OFDMA comment and IoT and basically say IoT is a place where we find cheap chipsets because of the nature of the devices, and we're still strong with the IoT. Bring out 11N chipsets, let alone 11AX. So, totally agree the potential there, Tom. But how much IoT are you seeing that can do OFDMA out in the field, or are we really just building the road for the future right now?
So far, this is what I've seen. And if you're not watching me, I just gave a big 0. So we're not really seeing it in true IoT devices, but the potential for it, and this is the thing, it's when does the price point begin to make sense? And will it be in time? And what I mean by that, before people have already chosen to use other protocols and now they're locked into technology. So, you know, I think right now, today, at this moment, forgetting about cost, Wi-Fi 6 so Wi-Fi 6E specifically for IoT is one of the best indoor protocols that exists on our planet. I just think that if you factor cost in, all of a sudden it's not so exciting. And that's exactly the point. So it's will we get to that point where the cost comes down enough so that we can use it before we've already locked into other technologies, 802.15.4 based technologies, things like that.
I hope so. We all want to see an end to those 11N cameras that we're putting on our networks. But yeah, exactly the same feeling on Wi-Fi 7. MLO is a big ticket, and I think it has the potential to be industry changing for bandwidth and a reliability point of view. My big fear is that it's as hard as multi-user MIMO, and we wait 20 years for it to actually come about, because I want it today.
Yeah, I think like the whole Wi-Fi 7, I would agree with MLO, but all I would want with MLO is more like robust links, maybe some band steering, more robust connections, maybe smoother roaming, this kind of stuff. I'm not so much into the bandwidth bandwagon yet. But then again, I've failed my predictions for the future catastrophically before. So Tom is likely right on and there's always, you know, the need for more bandwidth anyway. But you know, mostly so far I've been on the camp of just give me more robust Wi-Fi, and that's what 6 gigahertz has been all about. And I kind of hope MLO will give us a little bit more of that as well. Anything else before we hang up? I know Tom, we've already kept Tom for 12 minutes over, as well as a lot of the audience. So audience, any other questions before we hang up, or any wishes for the next webinar? We will give you exactly 20 seconds to type. Okay, there's plenty of MLO discussion there. But yeah, if nothing else, thank you, Tom. Thank you so much. This was a really good lead-in into the world of active learning, Wi-Fi basics, and we will continue next time. Do we have a date set already, or?
I don't think we do. I think we said we would target sometime in May.
That sounds fantastic. And yeah, thanks for the shout outs, everybody, and for the reactions. Give it up to Mr. Tom Carpenter, and see you next time sometime in May is the exact date, apparently.
All right, sounds good. Thanks all.
All right, thank you.